An 8 kilogram block is on a friction-free slope at an angle of 30 degrees. And we've been asked to find the acceleration of the block down the slope. In order to find the acceleration of something, we must have a way of finding the unbalanced force acting on the block. Now to do that, we must draw in our forces acting on the block with the help of our axes drawn like that. So the first force acting on the block has got to be the weight of the block, which we'll draw in like that. Let's recap these forces. The other force acting on the block must be the normal reaction force. Remember, the block is pressing down on the surface of the slope and the surface will push back on the block. That's what we call a Newton pair, and that's where that force comes from here, the normal reaction force. There's no friction acting on the block, so that's the only two forces we have on the block. So now we have to resolve the weight component into its parallel component and into its perpendicular component. And to do that, we actually draw a little rectangle round the weight vector like that. There we go. And you can see we can draw in now the perpendicular component, which will be there. And we can draw in the parallel component, which is there. So now we have the situation where we have the forces all broken down into their components. Now the block is not going to be accelerating in the perpendicular direction because the normal reaction force is balanced by the perpendicular force of the weight. So there's no movement in that direction. But as you can see, the parallel component of the weight is going to be the force which is going to cause the acceleration down the slope. And remember, we can translate vectors. So this vector here can be moved up to there, and you can see it quite clearly. That's going to be the force which is going to cause the acceleration down the slope. And from a previous lesson, we know that the parallel component of the slope is equal to mg sine theta. So let's work out the acceleration or the unbalanced force acting on the 8 kilogram block. Now the unbalanced force in this case is going to be equal to, well, we just take all the forces acting down the way, is going to be equal to the parallel component of the weight. Well, take away nothing because there's no other force acting in the opposite direction. So the unbalanced force has got to be equal to mg sine theta, the force acting down the slope. We put in our numbers. The mass of the block is 8 kilograms times gravitational field strength, we'll call 9.8, times sine of the angle 30 degrees. Now when we work that out, we get an answer of 39.2 newtons. And we'll just write that down as 39 newtons to keep the two significant figures. So now we'll work the force which is actually causing the block to accelerate down the slope. It's that easy. How do we work out the acceleration? Well, we know the acceleration, we'll do this in blue, the acceleration of an object is equal to the unbalanced force divided by the mass of the object. So in this case it's going to be 39 newtons acting down the slope divided by a mass of the block is 8 kilograms. So 39 newtons divided by 8 kilograms is going to give us an acceleration of 4.9 meters per second every second. So the block will accelerate down the slope with an acceleration of 4.9 meters per second every second. What does that mean? It means the block's velocity will increase by 4.9 meters per second every second. In this worked example, we're asked to find the acceleration of a 10 kilogram block down a slope of angle 40 degrees. The force of friction between the block and the slope is 50 newtons. So to start off, to find acceleration, we must find the unbalanced force acting down the slope. And to help us do that, we set up our axis like that. All the forces acting down this way are parallel, and all the forces acting up that way are called the perpendicular forces. So let's start putting the forces which are acting on the block. The first one is the weight of the block acting straight down. And then we have the normal reaction force. This is caused by the surface of the slope pushing up perpendicular in the block because the block is pushing down on the surface. That's a Newton pair force. So that's the normal reaction force. One other force to put in, and that's the force of friction, which always acts in the opposite direction of the motion. And we know the block is accelerating downwards, therefore the force of friction will be acting upwards. So there you have it. There's our three forces acting on this block. So all we have to do is find the components of the weight force in the parallel and perpendicular directions. And to do that, we make up our little triangle. And we know that that vector here is going to be the perpendicular component of the weight. And we know this vector here is going to be the parallel component of the weight. And remember, we can slide vectors up, so that parallel component can be put up here like that. So there we have it. There's all the forces resolved for us, and all we have to do now is work out the resultant force down the slope. We know that the motion of the box is not going to be moving in the perpendicular direction, so the normal reaction force will cancel out the perpendicular weight component, so that's out, so have no unbalanced force in the perpendicular direction. But we are going to have an unbalanced force acting down the slope, and that unbalanced force can be found as follows. Unbalanced force equals the parallel component of the weight acting down the slope. Take away the force of friction, which we'll write as F for the moment. So the unbalanced force is equal to, and we know that the parallel component of the weight acting down the slope is always equal to mg sine theta. So we can put that into our expression, mg sine of theta, theta being the angle of the slope. Take away the frictional force. Okay, let's put the numbers. The mass of the block is 10 kilograms, the gravitational field strength is 9.8, and we're looking for sine of 40 degrees, the sine of the angle of the slope. Take away the force of friction, which is 50 newtons. And we're taking away the force of friction because it's acting in the opposite direction from the parallel component acting downwards. Okay, let's work out the numbers then. 10 times 9.8 times sine 40 is going to give us 63 newtons to two significant figures, and we're going to take away the 50 newtons of the frictional force, and we're left with 13 newtons. So the unbalanced force acting on that block is going to be of a value of 13 newtons acting down the slope. Now the acceleration is found as follows. The acceleration of a body is its unbalanced force divided by its mass. So the unbalanced force is 13 newtons, and the mass of the object is 10 kilograms, and therefore we're going to have an acceleration equal to 1.3 meters per second every second. Worked example number 3. A 12 kilogram parcel is pushed up a slope of 20 degrees with a force of 48 newtons. Determine the force of friction if the parcel moves up the slope with a constant speed. Now, if we've got a constant speed, it means there's no acceleration. The block is not accelerating. And if the block is not accelerating, we can use this statement. The forces are balanced on the block. So all the forces acting upwards will be balanced by all the forces acting downwards. Constant speed, no acceleration. So let's see where the forces are acting on this block. We put in our axes as usual. Next thing we do, put in the forces. We're going to have a weight force acting straight down. And we're going to have a pushing force up the slope of 48 newtons, which we'll represent by that vector there. And our third vector of force is going to be the reaction force of the surface on the block. Remember, the block is pressing down perpendicular to the surface, and Newton's third law says the surface will push up on the block, and that's what we call the normal reaction force. So there we have our three forces all lined up like that. So all we have to do is get our weight into its components, and we just simply do that little rectangle again round it like that, and you'll get used to this, and you'll be able to put the vectors in, the components in quite quickly. The perpendicular component is straight down, and the parallel component is there like that. And we have got one other force to put in, and that is the force of friction, which we've left to the last. And the force of friction always acts to oppose the motion, so the force of friction will leave here for the moment. So we can move this parallel weight component up to here like that. Now in the perpendicular direction, the normal reaction force will cancel out the perpendicular component of the weight. But if you look, we've got 48 newtons pushing up the slope, and we've got the parallel component dragging the box down, the parcel down, and we've also got to add on the friction, which acts in the opposite way where the box is moving. So the friction is acting down the slope as well. So there's our situation. So the unbalanced force we found out must be 0. So we have all the downward forces must equal all the upward forces. So we can write the following statement out. The downward forces, the weight parallel to the slope, plus the frictional force, must equal all the forces acting up the way, which we know is going to be 48 newtons. So what is the parallel force? Well, we know the parallel weight component is always given by mg sine of theta, plus the frictional force, and that equals 48 newtons. Put the numbers for mg sine theta, and we're left with 12, put a bracket around this, 12 times 9.8, the gravitational field strength, times sine of 20 degrees, plus the frictional force must be equal to the force acting up the slope, 48 newtons. Let's do our calculation. 12 times 9.8 times sine 20 is going to give us an answer of 40 newtons. So 40 newtons is pulling down the way, plus the force which is acting down the way as well, and that must give us a force of 48 newtons which is acting up the way. So you can see that the force of friction must be 8 newtons for that equation to balance. We can do it mathematically by saying the force of friction is 48 newtons, and take over the 40 newtons and subtract it, and we have the force of friction equals 8 newtons. And the force of friction always will be acting against the motion.
Physics is wonderful. Physics is cool.